So today your task is to do a couple of things. You should click around on this page, recognizing congruent triangles, tips for working with congruent triangles in proofs. Now, there's a lot of abbreviations here, but you really need to know what each of these abbreviations stands for. Two triangles are congruent if all pairs of corresponding sides are congruent and all pairs of corresponding angles are congruent. However, that's 6 measurements you'd need to know. There are 5 combinations that guarantee that there's only one way to build a triangle. And those are, this SAS stands for side, angle, side, and you'll be expected to know the theorem for side, angle, side, which is in your textbook. Now, I don't have the same page numbers that you have, so you're going to have to flip around in your textbook. I can tell you, though, that the math notes box is after 6.1.4, I think. At least that's the way this is organized. And the abbreviations are a little bit different than for similarity conditions. So for side, 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 we're not looking for 3 pairs of sides that are in proportion or have the same scale factor. We're looking for 3 pairs of corresponding sides that have equal lengths. So this is a really important document. The conditional statement is one you need to know. So that's what your congruent triangle toolkits are for, organizing this information. You're expected to not only write down the abbreviation, which is side, side, side congruence, where this symbol matters, but you're also expected to have this conditional statement. Excuse me. If all 3 pairs of corresponding sides have equal lengths, then the triangles are congruent. And that's shown in this drawing. So you're expected to copy this drawing showing 2 scalene triangles where this side is congruent to this side. It's marked that way. This side is congruent to this side, and this side is congruent to this side. Side, angle, side. If 2 pairs of corresponding sides have equal lengths and the angles between them. So this is marked with 2 tick marks. This is marked with 1. And the angle that is created by those 2 congruent pairs of rays is considered the angle between them. Then the angles are congruent. Angle, side, angle. If 2 angles and the side between them in a triangle are congruent to the corresponding angles and side in another triangle, then the triangles are congruent. This illustration shows that. So you're expected to have this in your triangle congruences toolkit, along with angle, side, angle, and all the words in the theorem. And this is an abbreviation for an angle followed by an angle. Won't that give you similarity? And then 1 congruent side. That'll give you sides with a scale factor of 1. If 2 pairs of corresponding angles and a pair of corresponding sides that are not between them have equal measures, then the triangles are congruent. And this one here, hypotenuse leg. We have a right triangle, and we know one of the leg lengths and and the length of the hypotenuse, and we know those are both congruent to each other. That is the one condition where side, side, angle actually does guarantee congruence. So your task tonight is to play the how-to game, first triangle proofs, but you're going to want to refer back and forth to this page or your congruent triangle theorems toolkit, where all of this is listed. So I'm going to be looking for the illustrative example, that's this. The theorem itself, that's this. And the name of the theorem, that's this. For each of these 5 sets of conditions. So this is how the picture should look when you open up the how-to game. But let's go ahead and start from your search bar. You probably have how to, it probably pops right up. Mine doesn't. So I'm just going to type in how. We're going to click on the word geometry under the guy's hand. And over here, first triangle proofs. And we're going to start a new problem. So here's my pair of triangles. Would be really helpful if I could write on it. Good. So I'm now telling myself that PK is congruent to PK, and I'm going to go ahead and set that reason right now. I know that that's the reflexive property. And I'm also told that PK bisects angle APB. Well, if it bisects the angle, then these two angles have the same measure. They're each half the measure of APB. And that's a given. And I'm told that PK bisects AKB. So AKB and AKP and BKP are congruent. So I see an angle, this guy right here, congruent to this guy, followed by a side, followed by another angle. So that's angle, side, angle. I'm going to pick that for the reason that my triangles are congruent. Now, I still need a reason for PK bisects angle APB and PK bisects angle AKB. Well, those are my givens. And I need a reason for APK being congruent to BPK. So that's, oh, I guess I can't erase here. APK congruent to BPK, that's because that's the definition of an angle bisector. I was told that they bisect, so that's what I'm going to choose for my reason. Now you may not get these right on the first try. You may say, well, I don't know what that means. All right angles are congruent maybe? Click around on here and see what happens when you get something wrong. So PK is congruent to PK. Well, that's my reflexive. I've already got a reason for that. Now AP is congruent to BP. See this right here? CPCTC. That stands for this phrase. Corresponding parts of congruent triangles are congruent. So that just means, well, if I know these two triangles are congruent, well then don't I know that AP, which corresponds to PB, is congruent also? So I'm going to check how I did on my proof, and I am correct. New problem. You're going to go around and you're going to mark the givens. AK bisects angle BAE. AK, BAE. So this guy is congruent to this guy. And it's going to be by definition of bisector. And AK bisects BKE. This is another angle side angle proof. So my triangles are congruent because of angle side angle congruence. BAK is, well, let's start at the beginning. These are my givens. First step is always the given. There's just nothing to even think about there. AK is congruent to AK. There's my reflexive property. Angle BAK congruent to angle EAK. Definition of angle bisector. Now notice in here there are some other definitions. I like the vertical angles, that's my favorite. Let's go ahead and try this one. Perpendicular lines form right angles. We know that's not the reason for this BAK congruent to EAK, but let's go ahead and see what it tells you. Well, it tells you which one is incorrect, so don't be afraid to make a mistake. And go ahead and say definition of angle bisector, check again, and you are correct. So you're going to have to do some analysis here. Maybe you'll even look up these other definitions, but do some scrolling around. Oops, I've got vertical angles are congruent instead of definition of angle bisector. So help each other out. Hang pictures to your comments if you've got a question for somebody to answer, and give this a try.